Well, hello everybody, and welcome to the second day of Materials Day. We apologize that we've had to do this all remotely. We were really excited about doing this in person, but we took on a decision that I think that was sensible based upon the data that we were seeing. And at the end of the day, we're trying to just get ideas across to you and to show you what the highlights and overview for the Materials Research Institute is for this last year, and also particularly around the theme of the intersection of materials and manufacturing and sustainability. And I want to thank all the people involved in that. Now, for those that are not familiar with the Materials Research Institute, this is an enormously rich and broad activity at Penn State. It involves over 330 faculty and involves over 15 different departments. And intellectually, when we think about materials, it can touch every domain of which goes into society, particularly from a manufacturing or an instrumentation perspective. One of the things that struck me is the breadth of which our faculty does imaging science. It ranges from some of our electron microscopists looking at the picometer level, and that may be looking at displacements of materials like ferroelectric materials or other types of displacive phase transformations, through to our astronomers that work particularly the X-ray optics for imaging outer galaxies and star formations in outer galaxies. And so that's like 17,000 light years away. So overall, if you take consideration, we are looking over 10 to the 33 orders of magnitude with our material scientists. So that's an enormous intellectual endeavor of which to consider materials as a discipline. So why does the MRI exist? Well, Penn State has made a commitment to interdisciplinary research. And our goals in terms of the MRI is to basically be as an impactful materials entity at a university that can compete with anybody in the world. This is both in the domain of research and in education and in service. And some of the ways in which we consider how to do that and where we're continuously trying to improve ourselves is in the translation of science, going from the materials to manufacturing to devices to then improve lives, developing interdisciplinary teams to really try and understand and innovate around complex problems, really promote materials-based discoveries, both by helping that to happen, and also as our faculty and researchers do that, work with our marketing team to get that message out of where the discoveries are. Enable the strategic faculty hires around areas that maybe would not have occurred in the normal siloed college and department framework, but looking across areas and being quite dynamic in terms of looking for new areas to invest in. And then also driving state-of-the-art infrastructure through our facilities, which we will talk about during this discussion. And also participate in the education of the next generation material scientists, because that pipeline for industry and university is an extremely important area. So a couple of things. There is a strategic plan which is now in its second year, of which we're trying to advance material synthesis, which I'll talk about here, enable a Center for Living Materials, develop state-of-the-art facilities, as said before, drive materials integration and prototyping, so really pushing up the TRL levels, advancing quantum science and quantum materials and devices, and develop sustainable materials and manufacturing, and to optimize the translation of materials discovery. Now, Penn State has an enormously active faculty that brings in lots of research, both from the federal domain and also the private domain. And Penn State in the area of materials ranks #1 in materials science and #2 in materials engineering, according to the so-called HURD report of the National Science Foundation. So we talk about these areas of excellence and bringing together multidisciplinary faculty. I want to talk about a couple of examples. One is the 2D Crystal Consortium. This is a National Science Foundation Materials Innovation Platform. The director is Joan Redwing, And this has just recently been renewed for a second wave of funding for the next 5 years. And this has a number of faculty involved with it, but I also want to call out Kevin Dressler, who's done a brilliant job in terms of the operations and the use of the facilities that the 2DCC coordinates. So it was with great pleasure that I would give Joan a chance to then talk and describe what the 2DC Centre is about and some of the vision that she has for that centre over the next 5 years.
Hi, I'm Joan Redwing. I currently serve as director of the 2D Crystal Consortium facility that we have here at Penn State. So the 2D Crystal Consortium, or 2DCC for short, is a national user facility that's funded by the National Science Foundation. And it's focused on advancing the synthesis of ultra-thin two-dimensional materials. So we were initially funded by NSF back in 2016 for 5 years, and we were just recently renewed for another 5 years. So the funding that we've received from NSF has enabled us to establish state-of-the-art facilities for 2D material synthesis. We've also developed advanced computational approaches to accelerate scientific discovery. The facility is used both by faculty, staff, and students here at Penn State, as well as researchers outside of Penn State in academia, national labs, and industry. And finally, we sponsor a variety of educational and training activities geared towards students and early career researchers. So the materials that we specialize in are two-dimensional semiconductors. So 2D semiconductors are materials that are ultra-thin. They're only a few atoms thick, yet they have electronic properties that are similar to that of more conventional semiconductors like silicon. But because they're so thin, they're flexible and stackable, and it's possible to make devices out of them that are very energy efficient. So they're of interest for applications like 3D integrated electronics, wearable electronics, flexible devices, and neural networks. Also, this family of materials hosts many other more exotic properties that make them of interest for quantum computing and communication. However, these are challenging materials to synthesize since they require nearly atomic level control of their structure and composition. And so the 2DCC facility was established by NSF to serve as a center of excellence to advance the synthesis and discovery of 2D semiconductors and related materials. And as a national user facility, we serve a wide range of researchers beyond Penn State. So this is a map that shows the geographical distribution of our users. It represents a wide range of different academic institutions, so R1 institutions, undergraduate institutions, also national labs, including Department of Energy and Department of Defense labs, and industry as well. For technology transfer, we also partner with Atomic. So Atomic is an industry university cooperative research center funded in part by NSF, which includes Rice and Boise State University. And also it includes over 10 companies that pay an annual fee to support the research. And they were recently renewed as well for another 5 years. We have a research experiences for undergraduate sites that's funded by NSF. This is a partnership with the Penn State Nano Fab to provide summer opportunities for undergraduates to do research in our facilities. And finally, we've partnered with Florida International University, a Hispanic serving institution, to broaden participation in 2D materials research through 2 programs. One funded by NASA to look at space-based applications for 2D materials, and a recently funded program by NSF called PREM, which is focused on the science and applications of 2D materials for quantum technologies. So looking forward, as part of our renewal, we have several new capabilities and initiatives that we'll be putting in place. So this includes new synthesis tools for controlled formation of 2D metals, and a unique double crucible vertical bridgman system for improved stoichiometric control of bulk crystals. We're also developing a glove box cluster tool to enable layer transfer and stacking without air exposure. And we have a facility-wide database called LIST, which stands for Lifetime Sample Tracking, that we developed over the past 5 years to capture all the synthesis and characterization data that we've produced on samples in our facility, So to build on this, we'll be developing cyber tools to make this data accessible for machine learning and other data science techniques to accelerate discovery. And finally, we've also initiated a visiting scholar program for graduate students and early career researchers at other institutions to enable them to come on site and receive extended hands-on training at the 2DCC facility. So if you're interested in any additional information on these activities, please check out our website. Thank you.
So, thank you, Joan. Recruiting faculty like Joan and others requires enormous effort and partnership with the deans and the departments. I'm very pleased to report that MRI has been co-sponsoring a number of co-hires over this last year. We've got 5 already coming on board. Yang Yang came on board in July, and we've got 4 other members of new faculty coming on board. Kanjun Yu, who we've got from University of Houston in the area of bioelectronics and biosensors. Ezra Clark, who's going to be a chemical engineer. Another catalyst person is Gina Guo, and also Daniela Hickey in the area of convergence and biomaterials in chemistry, in the chemistry department. And then I also want to draw your attention for some of the other faculty that we want to highlight, because in this time of COVID it's been very difficult for people to get to know each other, and that's very important with the interdisciplinary mission. So I really want to draw your attention to the latest Focus on Materials magazine, which is Meet the New God, which gives you a chance to be introduced to some of the intellectual interests of the new faculty that we've hired in the last 3 years. Thinking about pipelines and being a university, it's natural for even a research institute like the MRI to be involved in education. And I'm very pleased to report from the MERSEC, this is the Materials Research Science and Engineering Center that we have at Penn State, that is run by Vin Crispy, has made an enormous effort to really reach out to the public with K through 12 education. And so earlier this year, they've got a mission on material science to then use web teaching tools to really push the communication of where materials are important to society. And here more locally, and with using undergraduates who really want to understand instrumentation better, we did an experiment. We did an experiment of bringing 3 new undergraduate MRI interns on board to then work with some of our staff inside the Materials Characterization Lab. And I think all of us have been absolutely thrilled with the skill and the training that those undergraduates have got. This is so important to us that we're going to be expanding this program in the forthcoming year. But those students really were able to, in a very short period of time, be left alone running $1 million instruments such as the TEMs all by themselves and collecting data for other parties. And I think it was a unique experience of which all of us have learned a tremendous amount. Other forms of research, both our 2DCC and also the MERSEC have been thinking about how we can improve diversity and outreach and inclusion in the education program, particularly around research. And so with the National Science Foundation program, the so-called PREM, the Partnership for Research and Education in Materials, we now have new partnerships with the North Carolina Central University and the Florida International University. And we're really excited about how these interactions are going to then flourish and push new levels of education and learning. And likewise, we're always hosting the research experience for undergraduates. Again, we had to go hybrid this year, the second year in a row, but this year's theme that was run between 2DCC and our Nano Fab was scalable nano manufacturing of complex materials. Another way in which we have been doing outreach in the pandemic era is through connecting with industry, because we recognize that the world is continuously changing and research is giving new opportunities, and we believe it's our job within the Materials Research Institute to partner with industry, and in particular to also communicate advances. And so Dave Fecco basically launched a new scheme which we call Materials Spotlight Series, and this covered themes with our faculty in glass technology, powder processing in metals, and also catalysis. And in the framework of how we communicated this was obviously in a webinar type of a platform, but we also had engagement through the GatherTown platform, which allowed people to then mix and discuss and to act a little bit more normal in terms of the interactions. And this involved a number of participants, and then for us we also were able to get over 70 new industrial connections with the MRI with this program. And so this is something that Dave will be working on in the future. When the university has at least 350 faculty that is associated with materials, it's a question of then how do you maximize as an institute the impact upon those faculty and their students and postdocs to then enable them to do the best research. This means really investing in our core facilities. And so one example of some of the purchases for new state-of-the-art equipment that we've done this year and will be arriving in January of the new year is a second electron beam lithography tool, which allows us to then make structures at a nanoscale, which allows us to then have this optics that I spoke of before for space exploration, new types of electronic sensors, devices, new types of MEMS, devices for 5G communication, power electronic chips, building new types of transistors on 2D materials, quantum sensing and quantum packaging and neuromorphic computing, all areas of strategic interest to the MRI and the university as a whole. We've also changed our leadership. We've introduced a new faculty member, Daniel Lopez, who's joined the university and is a professor in electrical engineering. We're very pleased to welcome him, and I'm very pleased to introduce you to him in a few moments. And he and Chad, who is the NanoFab, Chad Eichfield is the NanoFab operations director, really runs the NanoFab for the university. And they have a number of new ideas with the new equipment, and here is Dan Lopez to talk to you about what he is thinking about for a vision for the MRI.
Good morning. I'm the new scientific director of the Nano Fabrication Lab, and I would like to give you here a brief description of the current state of the lab and which are our plans for the future. The Nano Fabrication Lab has an experienced group of experts in nanoscience with years of experience helping users not only from academia, also from the industrial and private sector. We are a unique facility in MRI, working in research activities including biology, physics, astronomy, electrical engineering, and material science. The diversity of our research is one of the things that make us unique in this field and position us strongly as a strong facility to educate the next generation of interdisciplinary engineers and scientists. Among our unique strengths, we'd like to list our versatility to deal with almost any material you can imagine. We provide also flexible access to modern tools that are easy to use, and we are now identifying modular spaces in our clean room that will enable separation according to different styles of research and the diversity of applications. As an example of the tools that we offer, I would like to mention that we just acquired a state-of-the-art electron beam lithography capable of resolution below 5 nanometers. This tool is key for the Penn State programs in quantum engineering, and it will be available to our users probably in the middle of 2022. In order to enhance our presence beyond Penn State University, we just formed a new scientific advisory board with where you can see the list of its members there. And as you can see, we have top scientists and engineers from the academia, national labs, and industry. We also have a new user executive committee with professors from across the campus, and their job is to work with us to help us to improve the user experience and to identify areas to grow. Based on these conversations, not only with our users, with faculty across the campus, and also with our sponsors, we have identified 3 strategic areas where the facility will enhance its efforts in order to grow and help the research and teaching activities across the campus. These are, as you can see there, nanoscale optics, hybrid materials integration, and quantum packaging. Nanoscale optics is an area where the facility has been working successfully for many years and demonstrated, for example, incorporation of nanoscale structure on top of large, non-flat macroscopic elements. These hybrid optical elements are now the next big thing in optics because they will enable novel applications in imaging, communication, and in microscopy. We also have identified hybrid materials integration as another strategic direction because of the expertise that already exists in the facility. This expertise helped the MRI to attract support to create the new Center for 3D Ferroelectric Microelectronics. And we are strongly also collaborating with the 2D Crystal Consortium and always exploring new links among our facilities. Another new strategic direction is what we call quantum packaging. The goal of this strategic direction is to develop technologies that will allow our faculty, our users, to interact with quantum systems. As everybody knows, quantum systems are very sensitive to external perturbation, and it's very difficult to integrate them with electronics and photonics. A particular example of a program that we are developing now is the fabrication of packaging for atoms that they can be used for timing and quantum sensing applications. This picture here shows the state of the art of what is considered the packaging, a good packaging today for atoms. And as you can see, is not compatible with conventional semiconductor processes and very difficult to fabricate. We have started a process to develop new packages like the one that you can see here that will be compatible with nanofabrication process. And we believe that these are going to be key to developing a new generation of what is called quantum systems on a chip. Please contact me or chat if you would like more information about the facility. Thank you for your attention, and we are looking forward to working with you and hearing any suggestion that you may have about improving our facility. Thank you very much.
So that's intriguing, Dan. Thank you very much. Another major core facility is, of course, the Materials Characterization Laboratory. And again, here we've invested in a number of pieces of equipment. It's really part of our strategic focus around convergent science. And you can see here that a new piece of equipment that will be arriving is the AFM IR system, the atomic force microscope that allows you to do IR at a nanometer scale. And even before purchasing this, we worked with Brooker Instruments to then feel out what sort of science we could do in this convergent space on their instrumentation. And it was that work that then led to us then making the institutional commitment to then buy that latest piece of kit. And you can see here that people like Dan Cosgrove and his group is using this for looking at cellulose tissue. And we've got other people looking, such as Kui Wang's group, looking at relaxer ferroelectric materials and really understanding both the alpha and beta polytypes of that type of material, and in particular looking at the nanopolar regions for the very first time with this technique. And this was then published in Nature Materials last year. But it will allow people to see new insights into materials, not just with normal imaging, but now with spectroscopy. And the combination of these techniques, we think, is going to be particularly important for the life science, material science overlap. So we're also strategically thinking about changing some of the culture that we have within the Materials Characterization Lab. And Josh Stapleton, the director, will talk to you about that. But I also want to call out Jeff Schellenberger, the associate director, who's particularly been inspirational in thinking about how we can improve and advertise our accuracy and precision of measurement taking, and how that will also then impact how we educate students and how we monitor equipment. And so here is Josh to really talk to you about how that's all going to come together and how we're communicating with faculty and driving this education.
I'm Josh Davidson. I'm the director of the Materials Characterization Lab, and just want to provide folks with a a variety of highlights of just great stuff that's been happening in the lab over the past year, as well as some of the plans moving forward. So kind of on the front end, introduce our website. We've made a variety of improvements on our website over the past year to really make it more functional as well as more educational. So if you go to our homepage, it's really clear how to start to work with the lab, whether you want to request a training, request an analysis, request your sample be processed, or one of our favorite, request a consultation, where you can just sit down, chat with staff about your project, identify the right solution or strategy for your need. I've also really started to build out our introductory materials online. So most techniques now will have a nice about 10-minute video introduction to the technique, as well as some interactive posters, which give folks perspective on various ways the techniques can be utilized. Beyond that, we've also sort of modernizing our educational materials. We really started to build a lot of nice modules within the Canvas sort of learning infrastructure. You can see here, this is just a snapshot from one of our scanning electron microscopy courses. We've got a variety of other techniques already built out in Canvas, whether that's Raman or X-ray diffraction or FTIR. And so really plan to build our educational materials moving forward in a Canvas structure, which allows us to deliver these in a variety of different venues, and also serves as a really nice sort of frequently asked questions for even trained users in the facility. Also spent a lot of time over the past 2 years exploring and optimizing opportunities around remote research, in particular looking at remote electron microscopy. Trevor Clark within the MCL has really done a great job piloting remote TEM and focused ion beam. These are capabilities that are available to any external entities to Penn State, whether this is industry or other academics. Had a great test case for this past summer, where a research group at Franklin and Marshall College, about 130 miles from State College, logged just under 200 hours of remote TEM time this summer, helping us really vet the approach. And it's really been quite exciting to see how some pretty simple pieces of hardware really been created and expanded utilization of some of the high-end microscopy in MCL. So if you have any questions about that, please reach out. Also looking at continuing to invest in our very practical, hands-on characterization education that we provide for students. Fundamentally, our core mission is education, and we want to really even up our game more in terms of the skills that we're giving students, the approaches that they learn, application of analytical techniques. So MCL is in the middle of forming several different small faculty working groups that are going to be technique-based to really help shape the educational and scientific priorities for the lab. Some of the things that we're looking at are expanded education, i.e., could we get into teaching 1-credit characterization courses? What could we do in summer workshops scenarios? We're seeing just a lot of opportunities in the open literature to improve education. There's some examples here. One is a basic tutorial was put out on powder XRD from Ray Schock's group here in the chemistry department. Another example of a need for this is a paper here looking at characterization of 2D materials that was co-authored by several MCL staff. And so we're looking to further our contributions in the education space, and doing this in partnership with faculty is one of the very exciting priorities we have for the year to come. This is related in many ways to our kind of educational priorities, but taking a little bit of a different spin on this. And our real goal here is to be a facility that is better communicating to our users in particular what goes on sort of behind the scenes. What is it that we are doing to ensure that instruments are calibrated, that they're accurate, that they're performing well? And one of the goals of that is so that when folks graduate from here, they have a better sense of what they need to pay attention to when they start to use other analytical instruments. So a lot of what we're doing behind the scenes, we're going to put some more energy into communicating some of these health checks so that users get a better sense of exactly what is it that we're doing. Just one example here in our XPS, past 5 years, on a monthly basis, we're collecting data to ensure binding energy accuracy, which is one of the key axes that you're dependent upon if you're making an XPS measurement. And so look for a variety of communications coming from NCL in the months ahead about various health checks and calibration of instruments. I want to briefly introduce one sort of new capability in MCL, and that is the work that we are doing with protochips. Protochips is a market leader in situ TEM cells, as well as kind of next generation TEM control and analysis software. We're right in the middle of implementing a significant installation of Axon machine vision software, which we're looking to as a really kind of evolutionary step in TEM workflow, particularly for in situ experiments, to really help capture the right pieces of metadata, help increase the success rate of in situ experiments, as well as provide a platform for some interesting kind of next gen data analysis approaches. This opportunity has really come to bear because of the uniqueness of the diverse research community that we have at MCL that uses the facilities, as well as the really significant collection of in situ TEM cells that we have that range from liquid to gas to heating and biasing. Look in the future for Penn State to be a host location for the in situ training academies that Protochips runs. So it's just a couple of minutes to introduce a few key topics. Glad to have conversations and update folks as needed on anything else that's happening in MCL. Thank you.
Well, as usual, you've been very busy in MCL, and thank you very much, Josh, for all your efforts, and really looking forward to some of these things that you're discussing and going to the next level for this particular activity. Thank you very much. Interdisciplinary science also requires interdisciplinary communication. And I'm very proud that our MRI team has really embraced this. We did this with both the artistic display that we worked with the university to have over our entrance in the Millennium Science Complex, and unfortunately that's now finishing. I want to draw your attention to the story of that. There's a whole series that then talks about this development, so I encourage you to have a look at that. And something else also connecting science and art that we have done, as our students have, and I think all of us that have done materials, as particularly the imaging side of characterization, we often see strange things that really surprise us. Now the MRI and material science and engineering have always ran an annual competition to then explore the art around those types of imaging. And we want to not just reward those fantastic pieces of art that we've collected over the years, but we will now show that in this display above our entrance, so we can actually communicate this not just amongst other material scientists, but to anybody that walks past our building during a football weekend, visiting the campus and so forth, and be intrigued also by the beauty of the art that lies beneath the scientific images that we have taken in various microscopy modes. So MRI and the rest of the university is very indebted to an incredibly strong team. We have over 70 employees that continuously help to serve the mission of the university, and particularly the materials domain. And one of our big events of the year is Materials Day, and because of that we put together a whole core planning committee that basically starts the decision almost after the end of the previous year. So we'll probably start meeting a month and a half from now about next year's. And this is the team that has done that: Dave Fecco, Donna Lucas, Jen McCann, Bob Cornwall, Mike Hickner, and our new writer for MRI, Jamie Overdick. And then also I want to call out Shana Wood, Bessie and Sam for also all their help in terms of video and the graphics. And we also want to thank people that have helped us to make Materials Day a success, the invited speakers. Thanks very much to a great presentation by Pete Rosell, for Laura Weiss for really kicking the meeting off, and our two speakers from Nestle, Nicole Kalamila and Jan Bruckelmeyer, for their very good contributions on thinking about how we can improve sustainability of food packaging. And also many of the other people that participated in the breakout sessions, which I hope you found quite informative in terms of all the things that we're trying to do about sustainability in manufacturing. And also the breakout session panelists that then joined those respective groups to then really push the dialogue around these niche areas that we think are very important. So, thank you again for joining Materials Day this year. It's been another very successful year. We continue to move forward to then drive the mission of trying to make materials better and better for the community. We hope that we make a difference to the product that we push out of Penn State, be it a student, be it the research, be it the translation into industry. And it takes an enormous team effort to do that. And again, thank you all. Please partner with us and work with us to then make us even better than what we are today, because only can we become better by working together. So I hope very much you'll have time to join us for the next session, which is a celebration of excellence, and particularly the excellence in regard to interdisciplinary research regarding materials with the Roy Awards. We will also cover the winners of the proposals that were put in for the seed grants on humanitarian materials engineering, and we will also make the announcement of this year's focused areas that we're going to be covering for seed grants. So please join me for that, for looking for opportunities to partner and opportunities to get funding to then push some new ideas. Thanks very much for listening. See you in a few minutes.